Assalamualaikum and hi everyone. Welcome to my channel. For physics lessons today, we are going to discuss a few examples of questions on paper 3, section A, question 2. These questions allocate 12 out of 40 marks for paper 3. The link to all questions which we are going to discuss today can be found on the video description below. So, you just click on the link to get them. But before that, you are advised to give a try on all 3 questions before referring to this video. Once you're done, then you may do the checking and compare your answer with the recommended one. So, are you ready to begin? If you are ready, then let's start with question 1. A student carries out an experiment to investigate the relationship between the collector current IC and the base current IB of a transistor. The results of this experiment is shown in the graph of IC against IB in diagram 2.1. Question A. Based on the graph in diagram 2.1, state the relationship between IC and IB. So this is the graph related to question 1. We have IC on the y-axis and IB on the x-axis. If you refer to the pattern of this graph, it is a straight line graph started from the origin. So, what can you say about the relationship of IC and IB? Yes, IC is directly proportional to IB. Next, determine the value of IB when IC equal to 25 times 10 to the power of negative 3 ampere. Show on the graph how you determine the value of IB. So this is the value where IC is 25 times 10 to the power of negative 3. But you can see that the line here does not reach this value. So, what you need to do first is to extrapolate this line. Then, you draw a straight line from the value of IC up to this point. And then from here, you draw a line to the x-axis. So, this is the value shows that IB is 0.2 times 10 to the power of negative 6 ampere. Next, calculate the gradient m of the graph. Again, you have to show on the graph how you calculate m. To find the gradient, first and foremost, we select 2 points on the graph and then draw the triangle. The size of the triangle must be big enough. So these are the 2 points which you are going to take as our references in order to determine the gradient. So how to find the gradient? Gradient is equal to y2 minus y1 divided by x2 minus x1. So the value of the gradient is 125 thousandths. Since both IC and IB are in ampere, so there is no unit remain for this gradient. Next, the relationship between IB and IC is given by the formula in which IC is equal to alpha IB, where alpha is the amplification factor of the transistor. By using your answer in B1, find the value of alpha. If you refer to this formula, IC equal to alpha IB, when you rearrange, alpha will be equal to IC divided by IB. So what IC divided by IB refers to? Yes, it is the gradient, which means alpha is equal to m. So alpha is 125 thousandths. Okay, then the emitter current IE is related to the base current IB and collector current IC through this formula, where IE equal to IB plus IC. Based on the graph in diagram 2.1, determine the emitter current IE when the base current IB is 0.3 times 10 to the power of negative 6 ampere. So we refer to the graph again. This is the value where IB is 0.3 times 10 to the power of negative 6. And first thing, we extrapolate this line. Okay, and then you draw a straight vertical line from this value up to this point, and then draw a straight horizontal line which intercept the y-axis. So this is the value which shows IC, in which it is 37.5 times 10 to the power of negative 3. So to find IE, we do the substitution for IB and IC. So IE is equal to 3.75 times 10 to the power of negative 2 ampere. And the last question for this, state one precaution that should be taken to improve the accuracy of the result of this experiment. So, what precaution you can write for this experiment? Position of eye perpendicular to the scale of emitter to avoid parallax error. The keyword is eye, perpendicular, scale, emitter. Students, emitter is a device which we use in measuring the responding variable, so it must be stated in your precaution. So, how do you think of this question? How much can you hit? Did you score a good marks? If you don't worry, don't give up. We have another 2 questions to try. Okay, let's continue with question 2. A physicist carries out an experiment to investigate the relationship between the velocity v and the time taken t of an object which is thrown upwards in the air. The results of the experiment are shown in the graph of v against t in diagram 2.1. So this is the related graph for question 2. A. Based on the graph, state the relationship between v and t. If you refer to this graph, we can see that it is a straight line graph showing that v is decreasing as t is increasing. So what can you say about this kind of relationship? Yes, it is v decreases linearly with t. Next, determine the value of initial velocity u. Show on the graph how you determine the value of u. Students, initial velocity is when t is 0. So what you need to do is extrapolate this line until it intercepts at the y-axis. So here is 24 meter per second, which means u is 24 meter per second. Next, number 3, calculate the gradient m of the graph of v against t. Show on the graph how you determine the value of m. Do you remember how we determine gradient in question 1? So did we apply the same method here? First, you draw a big size of triangle. Then, this is the 2 points along this line, which we are going to refer to determine the gradient. So substitute the value into the formula where m, y2 minus y1, which is 5 minus 24, divide by 2 minus 0. So the gradient is negative 9.5 meter per second squared. Okay, next, what is the physical quantity represented by the gradient graph in 2b3? So we go back to question 3. If you look at this unit, it is in meter per second squared. So what does meter per second squared tells you? Yes, it is deceleration. Why deceleration? Since the value is negative, means the object moving with a decreasing velocity. Number 5. Determine the maximum height as achieved by the object. So how to find maximum height? A maximum height can be determined by calculating the area under a VT graph. So this is the area under the graph, and the shape of this graph is a triangle. So how to find an area for triangle? It is half multiplied by y, which is 24, multiplied by x, which is 2.5. So the maximum height achieved is equal to 30 meter. Next, the B. Using the answer in 2a3 and 2a5, calculate the time taken for the object to fall down again by using the formula of linear motion. So this is the formula you are given with, where s equal to negative mt squared divided by 2. So we just do the substitution where s is 30, m is negative 9.5, and t is the value we are looking for. So t is 2.51 seconds. The last question C, state one precaution that should be taken to improve the accuracy of the result of this experiment. For this kind of experiment, there are two precautions which you can write. Number 1, repeat the experiment 4 times and find the average value. Second, eye must be perpendicular to the reading of stopwatch. The key word for the precaution is given in the yellow highlighter. Repeat 4 times, average. Eye, perpendicular, reading, stopwatch. So how do you find this question? Did you score a better marks compared to the first question? Congratulations if you did. But if you don't worry, you still have one more chance in question 3. Okay students, now we have come to the final question for today, question 3. A student carry out an experiment to determine the density of a liquid rho and the volume V of a cylinder rod. The result of this experiment is shown in the graph of mass of liquid displaced M against depth of cylinder rod immersed D in the diagram below. So this is the graph related to the experiment, where on the y-axis is M in unit of G, gram, and on the x-axis we have D, which is depth, in a unit of centimeter. The first question, based on the graph, state the relationship between M and D. So I show you the graph again. It shows a straight line graph which is started from the origin. So what can you say about the relationship of M and D? Yes, M and D is directly proportional. Moving to the next question. Determine the mass of liquid displaced M when the depth of cylinder immersed is D, 6 cm. Show on the graph how you determine the value of M. Okay, so we refer to the graph again. So this is the value where the depth is 6 cm. So you draw a straight vertical line to this point and then match it to the y-axis, which show the value for m. And from here, the mass is 53 gram. Okay, for this question, there are several answers which is accepted. So for this one, the ranging is in between 53 until 54 gram. Number 3, calculate the gradient K of the graph. Again, show on the graph how you determine K. Okay, so we go back to the graph, and again, how determine a gradient. First and foremost, you draw a big size of triangle, and these are the 2 points along this line which we are going to use in order to determine the gradient. So substitute the value into the formula where K equal to y2 minus y1, which is 88 minus 0, divide x2 minus x1, which is 10 minus 0. So the gradient is 8.8 gram per centimeter. Gram is the unit for mass, which is on the y-axis, while centimeter is the unit for the depth, which is on the x-axis. Or you can also calculate gradient when you are choosing this point. 70 minus 0 divided by 8 minus 0. So the gradient is 8.75 gram per centimeter. So this is the acceptable answer for this question, ranging from 8.75 up to 8.8 gram per centimeter. Next, the density of the liquid rho is given by the formula rho equal to K divided by A, where K is the gradient of the graph, and here the value of A, which is area, is equal to 7 centimeters squared. Calculate the value of the density of liquid rho. So, what we need to do is, you just substitute the value into the formula, where this is the gradient we determined earlier, 8.8, divided by the area, which is 7. So the density is 1.257 gram per centimeter cube. If you are using the other answer for the gradient, so it will give you a density of 1.25 gram per centimeter cube. This is the acceptable answer for the density, ranging in between 1.250 until 1.257 gram per centimeter cube. Okay, and for question C, the mass of liquid displaced is given by the formula m equal to rho v. Using your answer in B, calculate the volume of the liquid displaced V in an SI unit when mass of liquid displaced is given at 80 gram. Remember class, the SI unit for volume is in meter per meter cube. Yes. So, this is the formula you are given with. So M is 80 gram. This is the density we determined earlier, multiplied by V. So V is 63.644 centimeter cube. But since they ask you to place the value in an SI unit, which is meter cube, so 1 centimeter cube equal to 10 negative 6 meter cube. So the final answer in the SI unit of meter cube is 6.364 times 10 power of negative 5 meter cube. Or if you are using the other unit for density, this is the answer you are going to get with. So the answer is in between this range of 6.364 until 6.4 times 10 to the power of negative 5 meter cube. Okay, and the final question D, state one precaution that should be taken to improve the accuracy of the result of this experiment. Again, this is the precaution we can write. Repeat the experiment 4 times and find the average value. Okay, so I guess that's all for today. Hopefully, by doing these 3 exercises, more or less will help you in preparing for your coming exam. Good luck for now. Don't forget to subscribe my channel for more physics updates, and thank you for watching. Bye!